Okay, everyone, and welcome to this session, Chaos Engineering for SQL Server. Just a very quick bit about myself. My name is Andrew Pruski. I'm a field solutions architect for Pure Storage. And before that, I was a SQL Server DBA for around 15 years for my sins. I'm originally from Swansea in Wales, but I've been living in Dublin, Ireland for the last near 10 years now. So it explains why my accent is a bit of a mishmash here, there, and everywhere, and also why I cannot handle this weather in any way, shape, or form. I'm going back to Ireland tomorrow. I'm going to be very looking forward to my 5 degrees and drizzle. My contact details are on the slide there, at dbafromthecold on Twitter, and dbafromthecold@gmail.com. So if you have any questions after today, or you just want to reach out and talk about tech, please feel free to do so. I'm always willing to talk about this stuff. My blogs as well, dbafromthecold.com, posted mobile articles about chaos engineering, loads of stuff about Kubernetes, SQL Server, VMware, anything I basically find interesting. You're more than welcome to check that out. And then, finally, my GitHub account. All the slides and the code for the demos that we'll be running are on my GitHub, and I'll post a link to the exact repo at the end. So, on to the session. The aim of this session is to give you an overview of what chaos engineering is, the basic principles behind it, and then we'll go into actual implementations of chaos engineering using SQL Server. Hey, I'm a former DBA, we're going to bring things back to SQL Server. And then we're going to run a chaos engineering experiment in my lab in Azure to test how SQL Server high availability works. But first things first, what is chaos engineering? Now, the definition on the slide there is from the principlesofchaos.org website, and it says that chaos engineering is a set of principles or methodologies that are applied to production systems to see how they react when they encounter failure. Basically, what we're doing is resiliency testing. But we like our fancy words in tech, so we call it chaos engineering. The idea here is to test specific things in production to see how they react. If they react the way we expect them to, then we've built up confidence in our systems. If they don't react the way that we expect them to, then we need to go and have a look to see maybe if there's a misconfiguration somewhere, and we can go and rectify that. So that's all we're doing. Specific tests against systems to see how they react. Now, before we go any further, I want to just mention one thing out there about chaos engineering, because there are misconceptions out there. And that first one being breaking things in production. We are not here to break things in production. If I said to my manager, hey, we're going to start having more production outages now because I am an engineer of chaos, I would be walked out the front door fairly darn quickly. We are not here to break things in production. We are here to write tests and experiments to see how things react when they encounter failures. But do we need to go near production? Well, not really, and especially when you first start getting out with chaos engineering, don't go anywhere near your production. Have a staging environment, have a development environment, run it in a lab that you've built like we're going to later for the demos in Azure. Because guaranteed, if you just deploy this stuff, train to production, you're going to be sitting in an instant review going, yeah, well, haha, I'm a chaos engineer. Things won't go well. But if you are going to run these things in a staging environment, make sure that your staging environment is configured the same way as your production environment. So you're not going to get, say, maybe the size of databases or the throughput that you would in a production system in a staging environment, but say, if you have some sort of high availability system in your production environment, you need to have that in your staging environment as well, so that you can be, plucking a figure out there, 90% sure that when you run your tests in staging, you can replicate them in production. Cool. So let's talk about a little bit of history of chaos engineering, and who here has heard of Chaos Monkey? Yep. Okay. So back in August 2008, Netflix experienced a 3-day production outage. It was actually due to database corruption. Should have got some decent DBA. But anyway, this was back when they were posting DVDs to customers. So they couldn't post any DVDs for 3 days. Could you imagine if Netflix went down now for 3 days? Could you imagine if Netflix went down for 3 days during COVID? There'd have been riots. So they did an incident review, and when they finished the review, they decided to go from a traditional monolithic architecture in a data center to a distributed architecture up in the cloud, AWS specifically. And when they went to the cloud, they adopted the mindset of, in order to prevent failures, we will constantly fail. And out of that mindset, Chaos Monkey was born. Chaos Monkey's sole purpose is to go through their production environment and switch servers off. That's what it does. The idea here being that if their systems cannot handle a semi-controlled outage, how are they going to react in an uncontrolled outage? That's what it does. It is available on GitHub. It is open source. You can go and download it and deploy it in your production environment. I highly recommend you don't do that, but you can if you want to. But this is just a tool. This is a tool that they use. Chaos engineering is more of a mindset or a set of principles, methodology. Google and Slack have similar things. They have Slack has disaster piece theater, and Google has disaster recovery testing, which they abbreviate to DIRT. They can't really call it DIRT. But anyway, what they do is they gather engineers together and get them sitting down and thinking about how their systems are going to fail, and then start designing experiments to test those failures. So, how do we get started with chaos engineering? Well, you gather a load of people around, and the first thing to do is do a past instant analysis. What has previously gone wrong in your production environment, in your environment, any environment? How has the system failed? What technologies or strategies are now in place? And what was learned from those failures? So we have, say, a production SQL instance. It's a single instance. It's running in production. It goes down for whatever reason. We bring it back up, and we decide that we need some sort of HA strategy in there to prevent this happening again. Now, that HA strategy could be, we could cluster it. We could build always-on availability groups, pretty much the standard. We could use mirroring. We could use replication, if you're nuts. But it is a valid HA technology. So, with our chaos engineering experiments, we could then test that HA strategy, because we want to build confidence in our systems that they will react the way we expect them to when they encounter failures. So this is the best way of starting with chaos engineering, is start to think about how you're going to design experiments, a past instant analysis. Another really good one, and I drew this graph myself, is I'm not a graphic designer. Something called a likelihood impact map. And this does exactly what it says on the tin. You start thinking about how things can fail in your environments, and you rate them on the likelihood and the impact of them. This, by the way, get a load of engineers in a room and get them thinking about this. After the first couple, it's like drawing blood from a stone. But once you get them talking, they'll come up with loads. And people do tend to be either over-optimistic or pessimistic when they start talking about failures in their environment, and I'll let you guess which way I fall on that side. But if that happens, they're all bunched down here, or they're bunched up there. Zoom in on them, do it again, and keep doing it until you get a nice spread across the graph. And what you're looking for is 3 or 4 up in the red there that are your prime candidates for your first chaos engineering experiments. Because remember, what we want to do here is we want to run experiments that have an impact or are likely to happen. We don't want to run tests against something and go, hey, our system's reacted exactly the way we expect them to. And someone going, yeah, but that's never going to happen in our environment. You've wasted everyone's time. Get rid of this chaos engineering nonsense. Go back to doing your job. We want something that's going to have an impact, and that is likely. So let's start thinking about potential scenarios that we can test. So we already mentioned high availability. We've got, say, fairly standard, a primary and a secondary server in an AG. Basically, the primary is replicating over to the secondary. Anyone here built an availability group? 1 or 2 of you? What's the first thing you do when you build it after you've got your databases in it? Fail it over. You fail it over to the secondary and fail it back to the primary. Make sure it's all working as expected. But that's not exactly how the primary is going to fail out in the real world. That's a real sanitized way of testing your high availability. So what about just yanking out the power of your production server and seeing what happens? Isn't that a more likely scenario to test? Isn't that more how things are going to crash out in the real world? That's something we could do. Okay, let's do another one. Backups. We all back up our databases, right? We back them up, we take our fulls, the diffs, our logs, we ship them off. But backups aren't backups unless you can restore them easily. Paul Randall, a guy from SQL Skills, tells a story about a bank that he was working with, where they were taking a full backup every month and then just taking transaction log restores. One day, they had a failure and they needed to perform a point-in-time restore. They restored their full, but then they had several thousand transaction log backups that they needed to restore. It took them 3 days, 4 days even, and the bank was down. I don't think the bank actually recovered from that. That is not a valid backup strategy. If you can't restore easily within your recovery time objectives to your recovery point objectives, RTO and RPO, then there's no point in backing up your databases. And there's hundreds of tools out there that you can use these days to test your restores. You can have a nice server in your production environment where you just run scripts built by a great module like here, I was about to say, DBA tools, a couple of authors there, just sitting there running through your restores. Run through your restores, do a check DB against them, and fire off an email if there's anything. It's a nice, simple chaos engineering experiment that you can run. So, story time. I was, a couple of jobs ago, sitting happy as a clam in my office, working away, and I was using a third-party tool to back up my databases. The reason I was using a third-party tool was because this tool had a feature on it that would compress my backups. We were running SQL Server 2005, no native compression. This tool would compress my backups. Great. And I had a nice little GUI with all my servers on it. Everything was green. I was sitting there smiling away to myself going, what a great DBA am I, and all this. Until one day, a developer came up to me and said, hey, we've accidentally deleted a whole bunch of data off this database. We need to do a point-in-time restore. And it was a 3 terabyte database. Wasn't too bad. And so I was like, yep, no worries. I've got my little GUI here, and it says that backup was taken. So I've got my full, my diff, all my logs. I could put the time in. And so I went, yep, I'll do that now. Won't take long at all, because I've got this little feature at the bottom that says instant restore. I was like, ooh, who wouldn't want to instantly restore a 3 terabyte database? So I ticked the little box, hit execute, and it went up to 99%, where it stayed for 5 hours and then failed. I hadn't been testing my restores using that feature, so when I really needed it, it didn't work as I expected it to. I didn't have confidence in it. I mean, the way I fixed it was basically after it failed, I did it again and didn't tick that box, and it took another 5 hours with a load of developers standing over me going, I thought you said this would be pretty quick. And I'm sitting there going, yeah, all right, how about I'll go away. Anywho, when we are using processes and things, we need to be testing them as experiments to make sure that when we really need them, they behave as expected. Let's do another one. Let's do monitoring. Guess what? Your monitoring systems are a point of failure. I used to work at production DBA. We had a system called Nagios that when an alert would pop in there, it would go up to PagerDuty, page me, and I'd go and have a look. That system, if it went down, I would have no alerts coming from my production system. So that needed to be highly available, and we could test that. But also, if you think about it, when do we get alerted? Think about there's a runaway transaction on a database server, and it's churning through that transaction log, and the log is getting bigger and bigger, and the space on the drive is getting smaller and smaller. When do we get alerted? Do we get alerted going, bang, drive full, go look, go sort it out? Or do we get an alert saying, there's unexpected growth on this transaction log, you need to go and have a look at what's on that server? That's a really simple chaos engineering test to run. Point your monitoring systems at a dev system, run some terrible transact SQL code. I can help you out there. And we'll run it, we'll fill that log up, and we'll see when we are alerted. Okay, let's do another one. Probably the most common one out there. So this is the really most difficult one to write experiments for. Hands up. Who's done this? Who's run an update statement without a where clause on a production system? Come on now. When I talk to DBAs in the job I'm now, and I mention this, or I'm talking to sysadmins and say, if you ever talk to a bunch of DBAs and one of them says they've never done this, they're lying to you. This case in point, a couple of jobs ago, working with a very good DBA, I won't mention his name. Hi, John. He took a load of code from source and was from source control that one of the devs was saying we need to update this. We need to update this one row in a production table. And, well, the idea was he was updating a voucher code in a voucher table for a specific transaction. And he grabbed that code, dropped it into Management Studio, hit execute, and as he hit execute, he realized he'd missed the where clause off and updated every single record in that table. The outcome of which was until we got it fixed, it took us about 20 minutes. Did a point-in-time side-by-side restore and get the data back. A 15% discount was applied to every single transaction that company did. A lot of happy customers who were like, "Ooh, I've got a discount." Not a lot of happy business owners. This is a really tricky one. The first thing I'd say is, should he have been allowed, or just should he have done an ad hoc update to a production system? That piece of code that needs to run should have gone through a deployment pipeline. And that's where we can run some tests. We can push crappy code through a deployment pipeline and see if it flags up, hey, this doesn't have a where clause. And that's what we ended up building. We ended up building something with Octopus Deploy that would analyze code before it got deployed out into production. And we could test it. We could chuck some horrible stuff through and see if it flagged it up. That took us about a couple of months. And in the meantime, what we actually did was we took our sysadmin rights away from our AD accounts, gave us SQL authenticated accounts. So if we wanted to go into production and do something that required more than read-only access, it just put that extra step for us to actually think about what we were doing. It's not infallible because you can just go, yeah, I know what I'm doing, and do it anyway. So there's a tool called the SMS Toolkit as well that would highlight any code that was missing a where clause. Again, not infallible because you can sort of just start, it pops up a box going, "You sure you want to run this?" And you go, "Yeah, no, of course I know what I'm doing." Execute it anyway. And then go, "Oh, God." Yeah. Right. Okay. So that's it. But that's a test of your deployment pipelines. And you can throw chaos engineering experiments to that and see if it reacts the way you expect, or it just allows the code to go through. Let's do another one. Probably one that I talk to people a lot about, and that's disaster recovery. Who here has got a valid disaster recovery plan for their production environment? 1, 2, 3. We've got a few. You need to have a DR plan, and it needs to be tested on a regular basis. Now, managers hate DR, because it's expensive, and hopefully you'll never have to use it. And I've heard some quality plans. One of them was we had a staging environment in AWS, and that was, we'll restore the databases into staging, and that'll be our DR plan. And I'm sitting there going, and when the company folds, I'll be sitting there going, big banner with "I told you so" sitting on the side. But it needs to be tested on a regular basis. And people have some bonkers ideas about, we're running in a private data center. Nothing could possibly happen. A company I worked for in Dublin, running everything in a private data center, didn't have a DR plan, specifically because the private data center handles everything. That private data center, about 4 years ago now, had a power outage. They were out for 4 hours, during which that company was totally down. Couldn't enact a DR plan because there wasn't one. So they were actually down for longer than 4 hours because when they brought the systems back up, all their firewall rules were messed up and they had to figure out how to get all that sorted. So you need to have a DR plan, and it needs to be tested on a regular basis. And that is prime for chaos engineering experiments. I actually want to mention another one that isn't on the slide here, and that is the personnel element of working with production systems. Who here has ever worked with someone who was the font of all knowledge for a system? They installed the system, they maintained the system, they troubleshooted that system. Yeah? Anyone? I definitely have. Has anyone been that person? Yeah. Simulate them being hit by a bus. Take them out of the room. Simulate that system going down. Play, it's like a war game play. Say, that system's gone down, can you fix it? Can the rest of the team fix that system without that person being in the room? If they don't have the knowledge, do they have access to the knowledge? Can they get on wikis? Are there runbooks? Are there things that they can get to so that they can fix that system? A really good chaos engineering experiment to run. Take them out of the room, because that one person will have a field day watching this going down. Going, nope, they're getting that wrong. Nope, they're getting that wrong. And then you can sort of say back to them, going, well, why are they getting that wrong? Update your documentation, man. Yeah. All righty. Okay. So, we've talked about how to perform a past instance analysis. We can do the likelihood impact map, and we've talked about some potential scenarios that we can test. Now we want to look at defining an experiment. And we want to have a look at what failure has the highest likelihood, highest impact, because remember, we want some actionable outcomes from this. And then what will we gain from testing that failure? We want some actions from this. Now, we either gain confidence in our systems, or we have to go and do an analysis of our production environment to see what went wrong. And then the final point here, is there anything else that can be tested? And what the question really is there something you haven't thought of? Which is a bit unfair. It's like, Andrew, is there something you haven't thought of? I don't know, I haven't thought of it yet. What I mean by this is go and talk to other teams. Don't just do your initial team. Go and talk to, from a DBA's perspective here, talk to your sysadmins, your network admins, talk to your report builders, talk to your end users, because I guarantee they will come up with scenarios of failures that you won't have thought so. And they'll love you for this, actually coming to talk to you and saying, hey, you know, what's your biggest issue? What can we test? Things like that. So let's get on and let's have a look at running a chaos engineering experiment. So what failure are we going to test? And this is up in the lab in Azure that I've got. We are going to see what happens if the primary node in an availability group cluster fails. So we're going to define our experiment now. We're going to say, hypothesis, what should happen if the primary node fails? And that is the listener of the availability group, the endpoint that all applications connect to, should move over to the secondary, remain online, and all our connections stay live. That's what we think should happen. That's what we want to happen. Method. How are we going to do this? Now, I said we can do alter availability group failover with T-SQL, move it backwards and forwards. It's a very sanitized way. Let's just stop the database engine service on the primary node. Let's shut it down with stop service force and see what happens. And finally, we have rollback. We want to be able, when we run these experiments, to put everything back exactly the way it was, just in case something goes wrong. Now, you want to keep these experiments as simple as possible. So for this one, all we're going to do is restart the SQL database engine service on that primary node. Cool. All right. Let me take a seat and let's have a look at our demo environment. And ooh, hello. Oh, okay. All right, so we're in Management Studio here, and we've got two nodes. We've got Chaos SQL 01 and Chaos SQL 02. Chaos SQL 01. Straight away. Okay, let's try that again, shall we? There we go, we're back. Oh, that better not have been the... No, it came up, didn't it?
It was Murphy.
Just enough to make me worry. Chaos in action. There we go. Right. There's auto patching on these things, and every time I go to a different time zone, I'm like, oh, what time is that patching started? Okay. So what we're going to do is we're going to use the T-SQL, and we're going to test our failover. We're going to go execute. And that's going to move our AG from 01 to 02. And if we do a refresh, we can now see 01 is our secondary, and 02 is our primary. Okay, cool. That's fairly standard. Let's let's make sure we can go back the other way. Going back to O1. And hit execute. Nice and simple. There we go. Okay, so we've verified that we can fail our AG over from O1 to O2 and then back from O2 to O1. But as I said, that is not the way it's going to fail out in the real world. So let's come into Visual Studio Code. And what I have here is a whole bunch of PowerShell that is... All right, I'm at a PowerShell conference. Please don't judge because I don't write very good PowerShell. All right, okay, let's have a look at it. Go away. Okay, fine. Control and dash. Oh, whatever. All right. So it takes a couple of parameters and it gets the listener of the AG just through a nice little command. And then I've got a whole bunch of stuff that just basically makes this look pretty. Because what we're going to do is run a testnet connection against that listener before we start. What we're doing is verifying that the listener's online before we do anything. And then we just got a nice invoke pester there just to make the output look really good with a bit of green saying, yes, listener is online, please proceed. We then go and grab the service on the current primary and we just stop service force it. We're nixing the database engine service. We then wait 10 seconds just so that the AG fails over and the listener comes online, and then we run our testnet connection again. And just because sometimes in Azure it takes longer than 10 seconds for that listener to come online, I'm going to retry just in case that second one fails. But if everything does go to work, we can then go, the listener's up and running, and we'll restart that primary server, putting it back exactly the way we are. And then if something doesn't go right and the listener isn't available, it will roll back the experiment by starting all the services, putting the servers back exactly as we found them once we start. So, conscious of time, let's go ahead and let's run our chaos engineering experiment. So, make sure I'm in the right place. I am. And we'll run our experiment. It takes two parameters, a server and the availability group name. I'm really good at naming things, so my availability group is called AGDR. And we're going to run it. So, first things first, we're going to run testnet connection against our listener. Making sure that listener's online. And this always takes a little bit longer than I like, just to make me panic and see things aren't working. And I definitely know it is available, so stop messing with me. Thank you. Listener is online. We are good to go and run our chaos engineering experiment. So we're going to nix the database engine service on that primary node. So we're waiting for that SQL Server instance to go down. Cool. We're going to wait 10 seconds. Primary instance has gone down. The AG should have failed over to the secondary. And then we're going to run testnet connection again against that AG to make sure that listener's online. Listener is up and running. We have had a successful chaos engineering experiment. We have verified that if we just nix our primary server, the AG failed over, listener's online, and the applications can still connect to our SQL instances. If we verify that in Management Studio, we can see O1 is now the secondary and O2 is the primary, exactly as we did with the T-SQL failover. Our AG is reacting the way we expected it to when it encountered a failure, and not just someone running T-SQL code to fail that over. Okay, we're not done. Let's do another one. This is just a reset, just in case, and then we'll clear this out. What we're going to do now is fail that back to O1, same as we did with T-SQL. So this time, the server's Chaos SQL O2, and we've got our availability group. So, starting off again, is our listener online on O2? And it is. Listener should be online. Great, that's online. So now we can nix the database engine service on O2. So that's going down. And now we're going to test to see if we've had a successful failover back from O2 to O1. Wait 10 seconds, and then we'll run testnet connection. Okay. That's taken a little longer than I was expecting. All right. Ha. Okay, no, we've had a failure. All right, our listener hasn't come online on this O2. So, okay, maybe it's Azure, maybe it just took a little bit longer and that listener didn't come online when we ran our test. So let's retry that connection. Let's run testnet connection again and just make sure that our listener didn't take a little bit longer to come online. See if there's an actual problem here. Right. Okay, no, we've got an issue. We've had a failure again. So, even though we could fail our AG, yep, it's all gone horribly wrong, so we've rolled it back. So even though we could fail over using T-SQL from 01 to 02 and 02 to 01, when we try it with just nixing the database engine service, something's gone wrong. Our AG hasn't reacted the way we expected it to when it encountered failure. It did the first time, but not the second time. Does anyone know why? I'm not asking you three. So didn't start the server correctly. The service, and the service was already running on 01, so it should have failed back easily. We'll have a look. It's a bit of an unfair question because there could be a whole bunch of stuff happening here. But if we come into the failover cluster log and do a refresh on the cluster events, and if we come here, have I got zoom it running here? The clustered role AGDR, our SQL instance, has exceeded its failover threshold. What on earth is a failover threshold? The comment there was, it's the worst setting ever. What this is if we come into the role and have a look at its properties, and we go to failover here, we have these settings. Oh, really? Let's try that again. There we go. So we have maximum failures in a specific specified period is 1 over 6 hours. So we could have one unexpected failure in 6 hours and the AG would behave as expected. But any more than that, the clustered role stays in a failed state on the primary server and won't fail over. So we've got a misconfiguration here. Oh, by the way, guess what the default settings are for clustered roles? Yep. So we need to make a change here. And, okay, what can that change be? When we did this in my production environment, we actually went for 2 failures in 1 hour, which I think is fairly reasonable, because any more than that, and it's sort of bouncing backwards and forwards, and then you've got another issue. But for say for this, we'll go for 10 failures in 6 hours. That is not recommended best practice, but just for purposes of demonstration, we can go ahead. Okay, so let's reset, make sure everything's back as it was, and now let's retry our experiment. So this time, we're still running on O2. O2 is still the primary. We're going to do a testnet connection, make sure that listener's online. Same as before, it's online. We can go ahead with our chaos engineering experiment, and that is nixing the database engine service on O2. So waiting for that to go down. And we're going to test our hypothesis. Is our listener online? Have we now had, after we've made our configuration change, a successful failover from O2 to O1? We're doing testnet connection again against our listener, and bang, our listener is online. So we've had a successful test this time. So from running this experiment, having the initial success and then the secondary failure, we've gone in, had a look at our configurations in our failover cluster manager, noticed that there's a misconfiguration there, made a change, and rerun our experiment to verify our change, and are now, our AG is reacting the way we expected it to when it encountered a failure. When I wrote this lab, I was sitting there, and I had, you know, where we get that cold, chill, sinking feeling, when I was sitting there going, I can't remember the last time I checked this setting in my production environment. And guess what? I went and checked, and I had a bunch of AGs with their cluster settings on the defaults, the 1 every 6 hours. So by even just running a chaos engineering experiment in a lab in Azure, I actually got some actionable results that I could go and apply to my production environment in my work settings. So that is pretty much everything I wanted to show you. Let's now go and have a look at, let's jump back into the slides. I want to finish this session by talking about a technology that I have been obsessed, maybe, yeah, for the last few years. It's Kubernetes. I got started with Kubernetes when back in 2015, maybe 16, I was talking to my QA department and they were having issues refreshing their QA environment. They used to rebuild all their VMs every month via a load of PowerShell scripts from source, and then they would build SQL instances and restore their databases. It took them about an hour per server because the hosts they were on were just absolutely rubbish. We decided to get rid of all of that and replace it with containers. The SQL instances would run in containers that they could spin up and their applications access those from a custom image that had just schema databases in. And it worked an absolute treat. We went from the ability to spin up a VM in around an hour to the longest it took us from start to finish with SQL running in a container and all the databases available, 2 minutes. We worked out that it saved us about a month's worth of dev time a year. But one day I came in and the host that all the containers were running on was down. No one could do any work until I brought that host back up and fixed all the containers. So we needed some sort of high availability solution. Now there's multiple orchestrators out there. There's Mesosphere, DCOS, Docker Swarm, but the king of the orchestrators really is Kubernetes. So I started looking at running SQL Server on Kubernetes, and was it viable? The main thing, what's the first thing you do when you're testing a new technology? Well, what's the first thing I do when I test? Break it, yeah? See, how is this going to break? Now, Kubernetes has high availability built into it. It has something called a reconciliation loop. You define your desired state of your applications in YAML files and deploy them to your production systems. At that point, they become your running state. And Kubernetes constantly checks between your desired state and your running state to see if they match. If they don't match, Kubernetes will fix them for you. Sounds prime for a chaos engineering experiment, right? And that's what I did when I was talking about, I'd moved jobs actually, and I was doing a proof of concept of SQL Server in Kubernetes. I stood in front of a load of management C people and explained that I wanted to move to SQL Server and Kubernetes for certain systems, not all systems. And I did a demo where I had a YAML file. I was in Visual Studio Code deleting pods, and they were spinning back up, and I was showing them how they worked. And afterwards, my boss said, well, it's really good, but it's very codey. Could you maybe jazz it up a little bit? I was like, jazz it up, as in jazz hands? He said, no, could you find a GUI to show to the C people how this all works? Could you slap some visual representation in front of it to show them how this works? And I was like, okay, I'll go off and I will find out something to work. And what I found was something called Kube Invaders. This is a chaos engineering tool to test high availability for applications in Kubernetes using Space Invaders. And this is what I did. I went and demonstrated high availability for SQL Server in Kubernetes in front of a load of C management people at my company. You may or may not be surprised that I no longer work there. Anyway, we've got a few minutes left, so let's have a look at running SQL Server in Kubernetes. I swear to God. Right. Okay. Talk amongst yourselves. No. Oh, come on, I've got 5 minutes left. There we go. Just long enough to make you worried. Okay, cool. Alrighty. So, let's come up to the top here. Let's clear this out. Get a bit of lag. Right, what I'm going to do is make sure I'm pointing to my Kubernetes cluster. Control get nodes. I should have a 2-node cluster running up in AKS. And what I'm now going to do is deploy 10 pods running SQL Server. Oh, I'm not in the right location. Thank you. Missed the very important first command. Jumping ahead. All right, let's try that now. We're going to deploy 10 pods running SQL Server. And if we come up here, I can watch my pod. I've got 10 pods running. So now I have my Kube Invaders game, and I can play my game. Good shot. And I can now see the pods, and it's very fast. And if I want to, I can come up here and just click Start, and it will do it automatically for me. And we can see the game playing, and we can see the pods being killed and recreated automatically because of the high availability built into Kubernetes. Now, it will eventually die because, well, you can see already it's not quite keeping up with the game. And those two server icons there are stress tests that run against the hosts. So not only is it now churning through CPU on the host, I'm constantly killing pods, and they're trying to come back up. As you can see here, we've got ones running and not, and eventually it will all die. But nope, I guarantee, hand on heart, this is how I demonstrate high availability Kubernetes at a company I was working for. I think this is probably one of the best GitHub repos I've ever found. I absolutely love it. If you are interested in this, I've got a whole way of getting this set up on AKS and in EKS that you can check out. But yes, it will just continue going. But we can already see that the cluster is not keeping up with. We've got more pods there, they're coming back, and it's basically not refreshing enough because the servers it's running on are basically churned through CPU. Okay, let's stop that, shall we? And we'll come back into the slides. Right, so there's the GitHub repo. Thank you very much. I have some resources for you on the GitHub repo here. Things like the Principle of Chaos.org website is the best place to start if you're getting started with Kubernetes. The QR code here will take you to my GitHub repo, where all the links there are for things like the Kube Invaders repo as well, with a whole guide of getting it installed. If you have any questions, please come and talk to me. Thank you very much.